Hello student, today I am going to start this network theory unit 2 part 5 and in which we have covered the reciprocity theorem and the compensation theorem. This is the last two theorem which are come under the unit 2 and let's go for the further and see what the statement of the reciprocity theorem. So it is stated that any branch of the network or a circuit, the current due to the single source of the voltage V in the network is equal to the current through the branch in which the source was originally placed when the source is again put in the branch in which the current was originally obtained. This theorem is used to bilateral network, obviously, which consists of bilateral component. What does it means? What the statement all about? The this phenomenon is commonly found in the nature. Beside of the electrical circuit, we have observed this phenomenon in machine, acoustic, or etc. When it is applicable to the physical system, we can interchange the excitation means sources and the response point without changing the response of the system to the given excitation. Means whatever the source you have given, we have to without changing the phenomenon of the circuit, we have changed the interchange the source, rather than you can say that the interchange the sources of the excitation means the source. You can change the source either put at the left side of the network or by right side of the network by the reverse direction without changing the any component. The same effect will be same. So this is all about the reciprocity theorem's statement meaning. It finds wide utility in the analysis and design of the system and also in the area of measurement. So this theorem is very applicable in the field of the measurement. For the better understanding, let us understand example of the telephone line between the two subscriber. See, suppose subscriber X and Y. If the telephone circuit comprises permissible element, then the reciprocal theorem permits us to assume that the transmission from X to Y is identical to the form of Y to X. So this general specification in practice the design of the testing of the line. So you might understand what are the meaning of the this reciprocity theorem in the field of engineering. And if we consider the two loop network means if two loop A and B of the reciprocal network N, and if an identity voltage E. Let's go for the further example. See, a location of the voltage source and the current source might be interchanged without change the current. This is all about the meaning of the reciprocity theorem. Hence, the polarity of the voltage source should be identical with direction of the branch current of each branch. Means, if in a network this current, this voltage and the current source is connected over here, what the reciprocity theorem do with this network, you can interchange these two sources. See, the current source you have to connect here and the voltage source you have to connect here. See, that's what happened if we change these two voltage sources. The various resistance, this R1, R2 and R3 and so on, is connected in the circuit diagram above the voltage source P and the current I. It is clear that the figure about the voltage source and the current source are interchanged for solving the network with the help of reciprocity theorem. The limitation of this theorem is that it is applicable only on a single source. Yeah, it is applicable only on the single source network and not in the multi-source network. The networks, when reciprocity theorem is applied, should be linear and consist of the resistor, inductor, capacitor, and the coupled circuit. This circuit should not be have the time varying element, so it is only applicable for time varying capacity of this network. So you can say that reciprocal theorem comprises the linear time invariant bilateral passive element, and it is applicable to the resistor, capacitor, inductor, and the transformer. However, both the dependent or independent sources are not permissible. So these are the limitation of the reciprocity theorem. You cannot use it in the field of this dependent or independent sources. Also, we are considering only the zero state response by the taking the initial condition to be 0. In this sense, the theorem is more restrictive than the earlier we have seen the superposition theorem. In superposition theorem, you have this which are the connected in the bilateral network. So here some restriction are there. So this is these are the first steps. Step first, select the branch between this reciprocity has to be established. Second, the current in the branch is obtained using the conventional network analysis method. The voltage source is interchanged between the branch which is selected. And the fourth one, the current is the branch where the voltage source was existing earlier is calculated. And the fifth one, now it is seen that the current obtaining in the previous connection, that is in step 2, and the current in calculated when the source is interchanged, that is the step 4, are identical to each branch, each other. So let's check some example. It is more clear to all of you how the reciprocity theorem is work. So see, in nutshell, I have shown this figure. So this is the figure in which we have applied the reciprocity theorem and find out the total current I. So what we have to do, this is the parameter which is given there. What you have to do, you find out the total current I by using this circuit, and then short circuit this terminal and connect this voltage source in the reverse direction over here, and then find out the current and see whatever the once we have find out the current in while using this circuit, it identical to find out the current will be identical while we are finding this voltage source connected like this. So let's go example for one by one step. So total resistance, so first of all we have find out the total resistance by series parallel circuit, and it become like this 15 ohm. See, this R1 plus R2, these two first of all taken R3 R2 yeah, R2 is parallel with this two circuit series in series. So connected this circuit series is parallel with this circuit R2, and the R2 is again series with R1. Then you have to find out the total resistance of 15 ohm. So when you have to find out the total current, so by applying the Ohm's law, you have to find the total current. It's 3 ampere. No, not 3 ampere. This is the branch current. This is the branch current. It's 3 ampere. IY means the total the current over here, and the total current is 1.5 ohm. Similarly, you remove the voltage source from here and connected here in the reverse direction, and then find out the total current and the resistance and the branch current. And once you have find out the total resistance, it is all about 10 ohm, and the current once you have find out the current, then the current it's not total current, it is the branch current. Branch current is 4.5. This is the current in this loop current. So this is the loop current, and again the total current is you have to find by the simple current divider rule. using this formula, and then it is equal to 5. So you have seen here, this is the 5 ohm, this is a 1.5 ampere current, and this is the 1.5 ampere current. So you have looked at that. This is the way you have to find out the current by using the reciprocal theorem, and it is proved that while you are changing the voltage source in either of direction, the current will be in the current will not change. Current will not change. The value of the current is same. So this is all about the reciprocity theorem. So earlier I have said that the some limitation of the reciprocity theorem, it is not applicable in the time varying element. It is not applicable. The circuit consists depending source, or it is linear, and this circuit consists of non-linear element like diode, transistor, etc. And the application of this theorem, the theorem is applied and analyzed and understood the generality of a high intensity source heating and the elastic bodies. This theorem is applied to determine this load generated surface where interhomogeneous isotopic half sets. These are the area in which quantum physics and in the physics we have used this reciprocity theorem to analyze the behavior of the physical system. So this is all about the reciprocity theorem. So in example, it is more clear that how the voltage source can be changed in a network without affecting the elements of the network. The current will be same. Now next, go for this one is the compensation theorem, and the compensation theorem states that the linear time invariant network, when the resistance R is uncoupled branch carrying a current I, is slight change means change in the resistance is denoted by delta R. The current in all the branches would change can be obtained by using that an identical voltage VC has been connected, that VC is equal to V is equal to I into R, and small and the R is all about the change in the resistance, and it is denoted as delta R in series with when all other sources of the network replaced by the internal source. So this is the network, this is the load current. So let's see what happened in the next slide. See, in compensation theorem, the source voltage VC, this is the source voltage VC, opposes the original current. In the simple words, opposes the in simple word you have might be understand. The compensation theorem can be stated as the resistance of the any network can be replaced by the voltage source having the same voltage as a voltage drop across the resistance which is replaced. So this is the main idea about the compensation theorem. So let's assume a load RL be connected in a DC network whose Thevenin equivalent, these are the Thevenin equivalent, gives the voltage V0 as the Thevenin voltage, RTH as the Thevenin resistance is shown in the figure. This is the RTH and this is the VOC, or you can VTH, is connected in the network and with the load RL. See, by using simple formula, I is equal to V divided by RTH by RL, as we have seen in the Thevenin voltage. Let's the load resistance RL to be connected is equal to slight change over here. See, R plus delta R, and delta R is nothing but the slight change in the resistance due to voltage source. Since the rest of the circuit remains unchanged, the Thevenin equivalent network remains as known as shown in the figure by this one. So what you have to do, see, convert this circuit by using this formula. Short circuit is this voltage, short circuit is voltage. So while you have short circuiting this voltage and connected to the VC voltage source over here, slight change in the delta current. So we have mentioned here this delta I, and obviously the resistance R plus delta R. Now new current is denoted by I dash, and the circuit is form by using this Thevenin equivalent circuit, the I dash become V0 divided by RTH, and this is the small change in the delta R with the RL. The change of the current being is termed as delta I, earlier I have said, and this delta I is equal to this I minus total I. See, now putting the value of equation 1 in the equation 4, we'll get the following equation by solving this formula. These two, this is due to the change in the this resistance R to delta R, and this is the current, Thevenin equivalent current. So once we have differentiated this to current, then we have find out by solving this equation we have find out the delta I, and this is the opposite sign of this. So as you know that the VC is I delta R as shown in the compensation voltage, therefore equation 5 became like this. So the compensation theorem tells us with the change of branch resistance, current changes, and the changes is equivalent to the ideal compensation voltage in series with the branch opposition of the original current, and all other sources in the network being replaced by the internal resistance. So this is all about the compensation theorem. It is might be clear of you by using the one example is taken over here. See, so this is the one network is that there, and find a change in the current in the resistance 2 and 6 resistance when the resistance variable branch is changing 3 to 6. This is the actually this one. I mean, the question is there, the problem is there. Let's find out the solution of this problem. By step 1, find the original current flowing to the branch in a variable branch, then find out the R equivalent. R equivalent is equal to 2 is this resistance plus 3 and 6 are parallel, so we connect this parallel, and the total R equivalent is 4 ohm. And then find IT. We have to find IT. I total is equal to 3 ampere. So the I is equal to this I. If we find this I is equal to, by using the current dividing rule, we find the total current and the divided by the resistance. So this is the 2 ampere. Now in second step, find the compensation EMF. So how do you find the compensation EMF? It's denoted by VC, and VC is equal to I and small delta R. So we have find the total current I is equal to, and delta R is the difference between the two resistors 6 ohm and 3 ohm. So total compensation EMF is 6 volt. And now what we have to do in step 3, modify the circuit, and developing this modified circuit, you have to connect the 2 or 6 ohm, this is VC over here, and small change in the R plus R delta R connected over here, and find out the delta I. So delta I, again you have the same step you have to follow. You find out the R equivalent, IT, and the delta I. So these 3 steps you have to find out, and then find out the current which is flowing over here, delta 6. So delta 6 is nothing but the total current and these two resistance. By current dividing rule, then you have to find out this 0.2 ampere. So this is all about the change in the current due to change in the resistance value. So this is a best example of the compensation theorem, so in which we have seen how the current values change due to change in the resistance, a small change in the resistance. So guys, look at another equation, another simple problem which is connected in series with this change. and this is for AC voltage. So same procedure you have to apply it and find out the change in the current. So today I am going to end my lecture. So in unit 2 of your curriculum, you studied here the superposition theorem, Thevenin theorem, Norton theorem, maximum power theorem, reciprocity theorem, and compensation theorem, in which you have deeply studies the statement, procedure, the step of solving the problem, and identify the terminals and what are the limitation, area of the application. So all about the area in which we have used the theorems you have studied here. So today I am going to be end my lecture of unit 2. Thank you.